The mission of U.S. Farmers and Ranchers in Action is to bring all of American agriculture together with farmers and ranchers at the center to collectively identify and tackle critical long-term issues. Our guests today are the researchers behind a new study from U.S. Farmers and Ranchers in Action called Enhancing Farm Profitability Through Nitrogen Efficiency and Yield Stability. It is a follow-up to the research USFRA published last year on the potential for U.S. agriculture to be greenhouse gas negative, which speaks to what's possible for agriculture. Today, we will learn more about this new analysis, what conservation and technology support it, handling low and high yield zones, profitability, and steps to take when adding this to your farm. I am joined with familiar voices. We have Dr. Jerry Hatfield. He's a retired laboratory director for the USDA Agriculture Research Service National Laboratory for Agriculture and the Environment. We also have Dr. Bruno Basso. He's a professor of Earth and Environmental Sciences at Michigan State University. Well, Jerry, to get started, can you provide a high-level overview of what yield stability is and what was analyzed in this study?
Yeah, if we start looking at this, everybody's familiar with yield maps, and farmers are paying a lot of attention to yield maps and everything else. Well, just think about yield stability as a collection of yield maps looking across the field to say, what is different about that in terms of saying, are there zones of that field that are always high yielding? Are there zones of that field that are always low yielding? And what causes that difference to occur across that? We really focused this just on corn across the Midwest initially to develop all of this. And we see this, and you see the driving factors that are behind this and everything else. But just think about a series of yield maps that are all stacked up over a number of years, but then technologies we have remote sensing that allows us basically to have that same surrogate for a yield map, but being able to obtain it in different ways. So we don't have to go back and ask a farmer for a yield map. We can actually derive that with a lot of different ways. So that gives us an idea of saying we have technologies that we can do this, and we've been able to apply this to really set a new stage for agriculture.
Jerry, you cut out just a little bit, so I'm going to have you answer two more questions. If you could tell us the timeline of this study and then what were the main findings?
Yeah, if you look at the timeline, you really go back to all of this. The timeline is, we've got 10 or 12 years of remote sensing data that comes into this. You look at that across 6 million acres across the Midwest, Bruno, and everything else. So we're not talking about just one or two fields. We're talking about the Midwest Corn Belt and being able to derive this. And you just look at this and saying, you begin to bring all these pieces together. Now we understand that there are parts of that field that always show up as low, and parts of that field that always show up as high, and then there are parts of that field that are unstable, and those are really weather dependent from year to year. And so you got the high and the low that are weather independent, and you got the unstable part that is weather dependent, depending on how that rainfall occurs. And so all of those begin to come together and saying, we have strategies now that allow us to really do a deep dive on all the agriculture production fields across the Midwest Corn Belt.
And let's jump into some of those strategies. I'd like to get both of your perspectives on this next question. And Bruno, I'll have you go first. What conservation practices and technologies work in conjunction with yield stability?
So as it was mentioned, yield stability is a very informative layers about performances within a field. So I would say that there are two immediate actions that a farmers could take. One is in the event that corn continues to be grown as it was in terms of the rotation system, the low yielding areas could certainly receive lower amount of fertilizer, bringing a reduction in expenses, which means greater profitability. Farmers should understand that they can make profit also by spending less. Unfortunately, the perfect year that we all wait for and are hopeful that these zones eventually will turn into a really good year, it's not happening on those low yielding areas. So reducing fertilizer in those zones is certainly one of the broader context of conservation. The other is it's a little bit of a more drastic action, which will be to potentially not grow corn the way you were doing it, and basically using any alternative system, which can be small grains, can be legumes, can be clover, can be pollinators, if they can obviously be supported by some payments and so on. So in that case, what we call precision conservation, it brings first the reduction on the expenses, which we show that unfortunately these areas are draining the farmer's bill down. The economics is really not there. But they're also creating a significant amount of pollution by losing this fertilizer that is not used by the plants, both in water as well as greenhouse gas emissions. So either you reduce fertilizer or you remove corn from production from these constantly low-performing areas.
And Jerry, your take, what conservation practices or technologies can work in conjunction with this?
I think now you really look and saying, we know that water is one of the driving factors that's causing this difference in yield stability. And particularly in the low or the unstable zones, because that's so weather dependent, is can we take now and begin to look at this aspect of regenerative practices and saying, if I put more organic matter into that soil and improve my water holding capacity or improve my infiltration, I can take care of this. I'm not going to have a major impact on that low stable zone, because it really is going to take a lot of different approaches in that. But that unstable zone, which is, maybe 40-50% of that field at times, there's a way that we can make those all work. So when we start looking at this and saying, I can reduce my tillage, I can improve my cover on that, I can begin to think about where I use cover crops into that system to improve the soil, we'll see dramatic impacts on that part of the field and everything. So now we begin to see that it's a puzzle. Now we've got nitrogen management, as Bruno talked about. We've got other management practices we can put into place that we can begin to look at it. But again, driving it back and saying, are these having a response? Because now we can begin to look and saying, have we made improvements into that field? And we can begin to see those changes as well.
So before we talk about those low and high zones, Bruno, you mentioned precision agriculture, precision conservation. Can you give us some examples? And then Jerry, if he misses any, you can add to it.
So like I briefly mentioned earlier, the low and stable zones is really part of the field that I would say opportunities, rather than, you really have to flip the basically loss of profit into potential opportunities. We have done this analysis over an extended, area, over 70-80 million acres of corn and soybeans, just to focus in the Midwest. The area was expanded across other places, but if we only focus on the Midwest, there is a really constant number, 30% of the field, almost independently across where it is. It's really constantly underperforming. And so, as I mentioned, nitrogen, it's really an opportunity, because there is no need to apply nitrogen if the last records of 15 years of yields has shown that independently on this high sufficient amount that you put, over 200 pounds, the plants still will be performing around the 130, 140 bushels, which is significantly inefficient. That plant will only take up, if you're lucky, 120, 140 bushels or so. So just to finish, we did this because farmers want evidence and they want, credibility from this study, and not as much as theory. Both Jerry and I think, have really characterized ourselves to help farmers make decisions with evidence and to implement it in farmers' field. So we, over the last 5 years, we have compared on hundreds of fields, actually thousands of fields, where nitrogen was applied at the rate of the farmer versus the rate that was advised based on the stability map. And all this film, all of them, all the fields showed that there was no nitrogen response in the low yielding areas. So demonstrating the value of these informative layers that could really reduce the amount of fertilizer going on these low productivity areas. At the same time, opposite end of the story, there was a response in the high yielding zones. And as Jerry mentioned, the unstable zones are the ones that we say you got to wait and watch depending on the type of year that you get. If it's wet and you are in a wet locations, obviously you will have a level of response. If you are on the hilltop and it's dry, you will have completely different one. That will take a little bit longer time to go into that. So I'll stop here.
Jerry, anything you wanted to add?
Yeah, and you think about this. I mean, I think when everybody says precision management, they think about, well, we're going to apply things at a square meter basis across the field and everything. But we're talking about 3 major zones within the field that we don't have to apply this and saying, well, I'm going to change from this 3 feet of the field to the next. Is that we're looking and saying we can do zoning across that field in a pretty broad sense. And begin to just change the rates in those 3 zones opportunistically and everything else. So I think it puts a different point on what we mean by precision management and precision agriculture.
Bruno, I want to read a line from the study and get your take on it. Yield stability analysis offers a transformative solution for tailoring nitrogen management. Across the Midwest, approximately 24 million acres fall into low and stable zones, representing nearly 30% of the cropland of corn growing areas. What can be done in the low and stable zones?
So farmers have heard this message, right? Reduce the fertilizer application. Now we're at a point where we could send prescription, and we are doing. My lab, it's really basically sending this prescription with low amount of fertilizer on the low yielding areas. The revolution would be if corn, which is a very expensive crop, farmers will resonate. The cost of the inputs has really basically surpasses the income, the possibility of making money, because the grain sales is so low, And so in that case, again, reducing fertilizer or removing corn from production for alternative land use will really be ideal conservation strategies on these zones.
Before we get Jerry's take on the flip side, Bruno, when I'm trying to visualize this, so, we think about when we're up in the air and fields look like a nice quilt. You're saying there's some low stability areas. I heard someone reference calling it a puzzle piece. Do you think we're not going to grow a big field of corn anymore? We're going to have little pieces individually in those low zones, or do a different crop in those low zones, or will it still look like one big cornfield?
No, I would say, well, first, I would say corn remains the predominant, but if a third of the field is losing $300 per acre, I will think twice on continuing doing the same thing. So 2 things, either reduce the input, reduce the expenses, and don't put as much fertilizer. That doesn't necessarily bring you to a break-even cost, because the seeds and all the management, it's still expensive. This puzzle could potentially be a reality. I mean, it could happen, but we're not talking about, small patches of land. We're talking, even the analysis was done on acre basis, 1 acre basis, cumulative. So if you're talking about, out of 100 acre fields, 30 acres, it's a subfield that could be managed. And farmers, as part of these grants that we have, conservation innovation grants, they either plant clover or any other crops in this. Potentially they received payment, and they planted native species, because it will bring the biodiversity pieces, which some of the consumer packaged goods and food companies are really looking into increasing the biodiversity, especially in places where cornfields are right next to each other and there is no break or buffer zones or any alternative land use. So that aspect is potentially coming up because there is a demand for a market. Either reduce the expenses or potentially get support and policies, either from market or from programs that will allow farmers to avoid this bloodshed of losing hundreds of dollars on areas that it wasn't intended. And so this brought some transparency to farmers. They can think twice about continuing to lose the amount of money that they're losing.
Now, Jerry, on the flip, what can be done in stable high zones to maximize on yield and profitability?
Yeah, the stable high zones, I think that's where we really need to be thinking about a lot of attention and saying, what can we do to make those even better? What can we do to improve their water availability? Couple that with nitrogen management. Always think about this nexus of water and carbon and nitrogen all together and saying, what can we do in those fields that take them, say, a lot of farmers will see that they're getting 350 bushels across that. If we could take that to 400 bushels and without a big change in terms of nitrogen inputs into that really, because that now really takes the profit to the next level. So we can take all those different practices that we've talked about for the low zones and the unstable zones and saying, if we apply those to the high yielding zones, what can we do to make that even more efficient and everything? So that becomes a quest and looking at and saying, well, we're just going to park those off to the side. But we'll take a look and saying, how do we bring all this together to really help that farmer go to the next level? Because I think what this study does is it really starts at making farmers ask questions about their system and what can they do. And not every practice will fit every farmer, but they can begin to explore how do they begin to make and look at this, realizing that there are different parts of that field that are going to respond differently.
A couple more questions as we wrap up this interview. Bruno, I want to read another line from the study. This strategy yields direct fertilizer savings of $30 to $40 per acre and avoids hundreds of pounds of CO2 equivalent emissions per acre. I know that probably perked up a lot of ears. Can you speak to this?
Yes. Well, that's a result of the analysis that I briefly mentioned earlier. So the saving on not applying fertilizer in these low yielding areas that have very clearly shown no response to fertilizer brings this type of savings. Now, farmers are much more, interested in being part of a solution to, building soil health and through regenerative practices. That's also because companies are requesting, the opportunity to procurement, buy grains with a more sustainable way of producing it. And so that translates into reduction of CO2 equivalent, lower losses of N2O emissions that come from fertilizer. So basically, if you apply less nitrogen fertilizer, you can claim avoided emissions, which are converted into CO2. So it's a win-win situation. They save money, and they also receive premiums and better markets for the reduction on the environmental impact.
Last question as we wrap up Farm Food Facts. I'll get both of your perspectives, and Jerry, I'll have you go first. Can you share what needs to happen next, and the steps farmers need to take for the next 5 to 10 years when using yield stability analysis?
Yeah, I think it's really quite simple, and we've touched on it in a couple different ways in here. I think farmers need to start realizing that they do have these zones within the field and begin to look and saying, what's my profitability map across that field? I mean, once you get it down to dollars and cents and not focus on yield, but focus on the return on investment, I think now they ask a different set of questions. And I think part of that is going to be the baseline. And then you can go in and saying, as I look forward into the next 5 or 10 years, do I focus on tweaking my nitrogen application? Do I focus on improving my soil's ability to capture water, convert that nitrogen back into grain, and really develop, I think, a 5 or 10-year plan for their fields on their farm, using this base level information, and then being able to take each year and look back and saying, am I making progress? And kind of this continual improvement process and everything else. So we adapt, and then we look, and then we tweak, and then we just keep doing that year after year. And I think once they do that, the amount of questions that they can start asking themselves, and with this information begin to really put a different point on how they really change their farming operation.
Now, Bruno, your final say.
Yes, I would agree with what Jerry said, but I would also say that farmers, the first step is providing these yield stability maps to farmers, make them available. And I would really like to thank the U.S. Farmers and Ranchers Association to be sensitive to this and involving, on this study. There is an opportunity to move the needle in allowing to build platforms where this yield stability maps and cumulative profitability, because it's not just last year because it was a unique particular year, but it's the cumulative profitability that really create a baseline to say it will be very clear that a farmer will say, I need to start losing money because I've lost profit over the last 10 years rather than just over the last 2 years. So making the stability maps available, converting them in profitability maps, cumulative profitability map. And then for every single field, there is a different solution. It's never the same rate. Every field, every farmer manages a different enterprise, different operation. But the opportunity of linking these new technologies that we're really mastering, both, image analysis as the images it becomes available, the runs of computer simulation models that identify the best rates, then in that case, we really have a significant, improvement in agronomic management for farmers going forward, where they can continue to be in business, make money, and also, why not, protect the environment.
Really exciting times. And thank you to Dr. Hatfield and Dr. Basso for your time and your expertise today. We'll include a link to the study in the podcast description. You can also subscribe to USFRA's newsletter to receive updates. USFRA plays the critical important role of creating opportunities for collaboration, information sharing, and solution development for the full agricultural value chain. We appreciate your time. And if you enjoyed listening to this podcast, please subscribe and rate us on your favorite podcast app. Tune in again. I'm Joanna Guza for Farm, Food, Facts.